Hello students, today is Sunday. Let me shoot the second video for you. Right? I hope you are able to understand the concepts in magnetism, magnetic effects of current. This is the last topic and it's very simple. Before we go into a galvanometer being converted into a voltmeter and into an ammeter, I want to say a few points here. In the last video, we studied about current sensitivity, the deflection produced per unit current. That we said NBA upon K. Now, how do we increase current sensitivity? We can say, if you want, IS, current sensitivity. N by increasing the number of turns, B by making the magnetic field more strong, A by increasing the area of cross section of the rectangular loop, right? We can have more turns, that is number, B is magnetic field and A is making more larger area. Or by decreasing the torsion constant or by decreasing the spring constant. And also we studied about voltage sensitivity, that is the deflection produced per unit volt, okay, that is nothing but phi divided by I, that is I into R according to Ohm's law, that is equal to either you use NBA upon K, we can say NBA upon K multiplied by R. Or we can say voltage sensitivity is equal to current sensitivity divided by the resistance. It's very simple. Voltage is here current sensitivity divided by the resistance which we have got. So I think you get an idea about all these points of sensitivity. These are useful in doing numericals. Okay. Now we will move on to the concept of galvanometer. Yes, of course in 10th standard you might have seen a galvanometer in the lab and voltmeter and ammeter. Let me tell you, a galvanometer has the scale which is at the center, that's the center point. Yes, it is not the center here, center, let us say. Yes, and the scale will range like this. Now it will be like this. Usually it starts from here 0 and ends at 30 milliampere. A galvanometer can measure only small current which is going to be in milliammeter, and it will have a pointer at the middle like this, right at the center. Again, we cannot really measure the current, only we can usually say what is the direction of the current. We use it usually for that purpose. So when current is going from positive to negative, maybe it will deflect towards the right, and maybe if it is going from negative to positive, it may deflect towards the left. We are going to only talk about only deflection towards right or left, and where this is the center point you are going to have. Now an ammeter or voltmeter is just opposite to that. It will have again the scale, but the scale will start from one end of it, 0. Maybe if I say, if the voltmeter, let us say if I have 3 volt and 1 volt, say 0.5, 1 volt, 1.5, 2, 2.5, 3. Okay, we can have it like this. So this is 3 volt maximum range. And here you will find that the pointer will be at 0 and the values will increase, right? 1, 2, and I said that is going to be 3 volt. These are all mediatory. Also you will find small divisions, and that will help you to find an accurate value. Fine. So now let us say, if suppose I have an ammeter, same ammeter you can have, for example 1.5 ampere you want to measure, same scale, it will have 0 and its maximum range will be 1.5 ampere. Then these values also will accordingly change. And you see the main difference between galvanometer and ammeter or a voltmeter. They have scale in one end of it and others having at the center. Now we have to convert this into this type. How can we do this? It's a very simple process. We are going to connect resistors, that's all. And you know that how to connect resistors, you know that also, either in series or in parallel. It is as simple as that. Okay, it's a very easy concept. Let us do it thoroughly. Yeah. Okay. See, what I am going to do, I am going to take a galvanometer. Galvanometer has its own resistance. It is made up of coil. Okay, let us say its resistance is G. And I am going to connect a resistance first in series. Let the resistance be R. And these are the two ends of it, A, and this end is B. Fine. This is B. I have connected the resistance in series. So what will happen? A current is going to flow through I. The current which is going to flow through is I. And the same current I is going to flow through. But galvanometer has a restriction. It cannot take any current. The resistor can take any current. But this galvanometer cannot take. So let us say the current which is coming through is Ig. That is the maximum current the galvanometer can withstand. That means in series the current is same, so this is also Ig. Okay, so the current flowing through is Ig. Now IgR is what? The potential difference across the resistance R. Similarly, IgG is the potential difference across the galvanometer. So what is happening, you see? The potential is getting divided. The potential is getting divided into two parts. So can I say this is the total potential? Okay. Now if this is the total potential, what formula we can make it? V is equal to V across resistor plus V across the galvanometer. That is, we know that V is IgR. So this is Ig into R plus through the galvanometer is Ig into G. Ig into G. So what is the common factor? Ig is common. So R plus G is the formula. That is V and that is V here. So let me bring the Ig down here in the denominator this side. Ig is equal to R plus G. What am I trying to calculate? What should be the resistance I should connect in series? In series to convert a galvanometer into a voltmeter. So in order to convert a galvanometer into a voltmeter, you connect a resistance in series and that is divided like this. So what is this resistance? From here we can say R is equal to V upon Ig minus capital G, and this is the formula. This is the formula for finding the unknown resistance, the resistance which we need to connect it in series. You will find that the resistance which you connect will be high resistance which is connected in series. Okay, a high resistance is connected in series. Okay, later we will study more about it. You will connect, this whole thing has become a voltmeter, right? And this has become a voltmeter now, whatever the range you wanted, but the voltmeter will be connected in parallel in any circuit. Check it why? Why should we connect a voltmeter in a circuit parallel? What is the purpose of a voltmeter? Voltmeter purpose is to measure potential difference. When it has to measure potential difference coming from somewhere, it cannot absorb or deviate current. It cannot do anything with the outside external current. So already it has high resistance. If that also consumes resistance, there is a dissipation of energy across this distance, or there is a voltage drop across this resistance, then the measurement will not be correct. So you have to connect a voltmeter in parallel in a circuit like in Ohm's law that you can study. So we have connected now a galvanometer converted into ammeter. Now I am going to move to the next idea, how to convert a galvanometer into a ammeter. Fine. Let me erase the board properly. Okay, now our next discussion is converting a galvanometer into an ammeter. Now, again I am going to take a galvanometer, and galvanometer has its own resistance, that is G. Fine. Already we have connected one time in series. Next time we have to connect, next option is what? We have got only one option, that is parallel. So I am going to take a resistance and connect it in parallel. Fine. Okay, these are the 2 points A and B. A current I is coming. We know it, we are going to measure current. I is coming. This is the junction. At the junction, what will happen? The current will divide into 2 parts. Through the galvanometer, it can have maximum limit, that is Ig. So the amount is being diverted, that is I minus Ig. Let us say 5 ampere current is coming. If 0.2 ampere can go through the, let us say, galvanometer, then how much current will come here? That is 4.8 ampere. This is just a simple example I am giving you, that is I minus Ig. Fine. So the current is coming through. The resistance I connected here, I call it as R, and again current is coming and it is going back out like this. In parallel, what remains the same? The potential difference. So the potential difference across the galvanometer coil and the resistor which we connected, this is called shunt resistor. This is referred as shunt resistor. This is connected in parallel. It is connected in parallel. So we will say whatever the potential drop across the coil of the galvanometer should be equal to potential drop across the resistor or shunt resistor. Let me write here PD across coil, galvanometer coil is equal to PD across shunt resistor, Okay, what is the value? We are going to use Ohm's law now. IgG is equal to I minus Ig into R. I minus Ig into R. Okay. So we wanted to calculate the resistor which we want to connect. So R is equal to IgG upon I minus Ig, or R is equal to IgG, like parlay G, IgG upon I minus Ig. You can put this in bracket like this, and this gives you the formula for the conversion. What should be the value of the shunt resistor in terms of coil, galvanometer coil resistance and the current passing through? This we can use it to measure current, and this will become an ammeter. The whole thing will turn to be an ammeter. Now, look here. An ammeter will be connected in series in the circuit. Why? Already the external resistance is in parallel. Okay, and the shunt resistance, parallel resistance will be a small resistance, or we can say a low resistance. I think if I am not wrong, somewhere I might have done a mistake little, just a bit. Let me check it now. A minute here. Yes. Yes, I am right. Yeah, I got little confused. Actually, I am not little well. I have severe cold. So I thought, let me do the video. I got little stuck here in this point. So you connect a low resistance in parallel. Right? Now, there you resist a high resistance in series, and here you connect a low resistance in parallel. So the concept is correct, but in the circuit you connect this in series and you connect that in parallel. Okay, so that the external current or voltage is not affected in any way. With this, we have completed this whole concept of it, right? And we began with Biot-Savart's law, Ampere's circuital law. Then we learnt about force on a charge. We said that F is equal to QVB sine theta. Then we spoke about current through a conductor. F is equal to BAL sine theta. And also we studied about two parallel wires, how the parallel current is affecting each other, force per unit length. And then we moved on to torque. Tau is equal to NIBA sine theta. Then I also used the term current into area as M, that is magnetic dipole moment, and we said that tau is equal to MB sine theta. And then we moved on further in the last video with the moving coil galvanometer, and we used the term current sensitivity, voltage sensitivity, and the lesson is ending with the concept of conversion of the galvanometer into voltmeter and then into ammeter. Thank you so much. Have a happy learning.